Hi, hello. Welcome to this video lecture. I am C. Usharani, working as an assistant professor in the Department of Artificial Intelligence and Data Science at Ramco Institute of Technology. In this video, we are going to discuss about the important topic in distributed computing, that is design issues and challenges. The design issues and challenges of distributed system has numerous challenges. They fall into three broad categories. First one is the issues related to systems and operating system design. And second one is issue related to algorithm design. And third one is issue arising due to emerging technologies. These three classes are not mutually exclusive. First one is issues related to system and operating system design. These are all the issues are arising due to system and operating system, that is communication, process, naming, synchronization, data storage and access, consistency and replications, and fault tolerance, security, and the scalability and modularity. First one is communication. In distributed system, need the mechanism for processes on different machines to talk to each other. For example, remote procedure call and remote method invocation, that is RMI. And second one is process. It involves the process and thread management at both the client and server environment. And third issue is naming. In distributed systems, need the schemes for names, identifiers, and addresses to locate the resource and process. It must be the transparent and scalable also. For example, when you access the www.google.com, you don't need to know its actual IP address or which server is responding. So the domain namespace, that is the naming system, it handles the transparently. And next one is synchronization. Since there are no global clock in coordinating the action across the machines. So the mechanism, it includes the mutual exclusion, leader elections, that is choosing the one coordinator among all the other nodes, and physical clock synchronization, that is approximating a common time reference, and global state recording, that is it capture the consistent snapshot for the entire system to state at once. Okay, and the next one is data storage and access. This can be fully covered with file system, how the data can be stored and accessed in the distributed computing environment. And it concerns how the data is stored and accessed across in the distributed nodes. And the next one is consistency and replications. The data is often replicated, that is, it copied across the multiple nodes to achieve the high scalability and availability. And next one is fault tolerance. Since components can fail independently, so the system fault tolerance techniques are used. First one is resilience and reliable communication. Next one is distributed commit and checkpointing and recovery, agreement and concession, failure detection, and self-stabilization. So these are all the fault tolerance techniques are used in the distributed system. Especially the checkpointing and recovery, agreement and concession, failure detection, it can be used in fourth unit. Okay, and next one is security. In distributed systems are more exposed to attack since the data travel across the network. So these measures can include cryptography and secure channels, access the control and key management. That is the generation and distribution, and explain it authentication and secure group management. Next issues is application programming interface, that is the API and transparency. First one, it can consist of a lot of type of transparency. First one is access transparency, that is the differences in data representation across the system. Next one is location transparency, and it hides where the data and resources is physically located. User get uniform access regardless of locations. Next one is migration transparency. It allows to relocating the resources without changing the name. Next one is replication transparency. User does not know if they are accessing the original data or replicated copy. Next one is concurrency transparency. It makes the fact that multiple user or process are sharing the resources simultaneously. Next one is failure transparency. The system remain reliable and fault tolerance. If the component can fall, user does not notify the failures. And next one is scalability and modularity. So it achieves using the techniques such as replication, caching and cache management and asynchronous processing. And the next category issues related to algorithmic challenges in distributed computing. Here, lot of issues are arising. First one is designing useful execution model and framework, and dynamic distributed graph algorithm and distributed routing algorithm, time and global state in distributed system, synchronization and coordination mechanism, and group communication, and distributed program design and verification tool. So first one is designing useful execution model and framework. Here the formal model is used for distributed computation. First one is interleaving model, partial order model, and input and output automata model, and TLA, that is the temporal logic of action. This can be used in OS. And next one is dynamic distributed graph algorithm and routing algorithm. Distributed systems are often modeled as the graph, that is nodes, that is computers, and the edges is network link. So these algorithms are needed to route the messages efficiently, even as the graph changes dynamically. And the next one is time and global state in distributed system. It connect to no global clock, and how to we even the define current state of the system when there is no single clock. These issues can be arised. And the next one is synchronization and coordination mechanism. Here, the lot of synchronization and coordination mechanism are used in the distributed systems. First one is physical clock synchronization, and the second one is leader election and mutual exclusion. Next, deadlock deduction and resolution. Next, termination deduction. That is knowing when a distributed computation has actually finished. And the next one is garbage collection. And that is reclaiming the memory and resources across the distributed nodes. These all the topic will come in third unit, that is the mutual exclusion algorithm. How the mutual exclusion algorithm can be chosen for detecting the deadlock. Next one is group communication. That is multicast and order message delivery. It is sending a message to the group of process, ensuring that all receive it and happen in the same order. So the message delivery, ordered message delivery is very important topic in distributed system. Next one is monitoring distributed event and predicates. Predicate means it is a conditions, it defined on the variable that live in the different process, is used to describe and detect a condition about the overall system's global state. And next one is distributed program design and verification tool. These tools to help build any formally verified distributed program are correct. And next issues is debugging the distributed programs. It much harder than debugging a normal program because of concurrency and replications. If any bugs are appear under the specific timing and interleaving conditions that are hard to reproduce. And the next one is data replication, consistency model, and catching, searching, scheduling is important issues arised in the distributed system. And distributed shared memory abstraction means the communication is done by the middleware by pausing the message. Even though physically there is no shared memory and middleware there is no shared memory in the distributed system. So the middleware can creating the illusion of shared memory by using the concept of message passing. It is related to the algorithmic problem of weight-free algorithm, mutual exclusion, and registered constructions. And next issues is reliable and fault tolerance distributed system. The deeper dive into the fault tolerance algorithm or concession algorithm, replication and replica management, and voting and parent system, distributed database and distributed commit, and self-stabilizing system, and checkpointing and recovering algorithm, and failure detectors. So these are all the issues can be erased under the concept of algorithmic challenges. And the next one is load balancing. Load balancing and performance in the sense, this load balancing is distributing the work even across the system. So first one is data migration. It's the ability to move the data around in the system as needed. Next one is computation migration. It is ability to relocate the running process to balance the workload in the distributed system. Next one is distributed scheduling. It achieves a better turnaround time for all the nodes under the task. And next one is real-time scheduling. It meets the quality of service requirements, that is the scalability, reliability, fault tolerance, and performance. So these are all the quality service requirements of the network. And the next one is performance. It involves defining the right metrics, that is what to measure, latency, throughput, etc. And it can use the measurement methods or any tools to actually evaluate the system performance. So these are all the issues can coming under the issues related to algorithmic challenges. And last issues is applications of distributed computing and new year challenges. These are all the some emerging challenges can occur in distributed system. Finally, it covered the new year application domains that introduce the some fresh design challenges. First one is mobile system, sensor network, pervasive computing, that is the computing embedded seasonally into the everyday environment. And the next one is peer-to-peer computing, and publish, subscribe, or content distribution and multimedia. Next one is distributed agent, distributed data mining, and grid computing, and security in distributed system. So these are all the some major issues can be raised in the application of emerging technologies. So that's all. So I conclude the main design issues and challenges can be raised based on the three categories. First one is issue related to system and OS design, and issue related to algorithmic design, and due to emerging technologies. So I hope the design issues and challenges in distributed system understood. Okay. So thank you.